So means for a benzene ring, we are adding concentrated HNO3, concentrated H2SO4. Then NO2 will be substituted. Okay. Let's see the mechanism. Now, see, for a normal benzene ring, when we add concentrated HNO3, concentrated H2SO4, one of the hydrogen is replaced by NO2. In this reaction, electrophile is NO2 plus. Electrophile is NO2 plus. And the mechanism of this reaction is electrophilic substitution. Electrophilic substitution reaction. Okay. So what is happening is, first let's draw the structure of H2SO4 and HNO3. Okay. Now H2SO4, sulfur, double bonded oxygen, double bonded oxygen. There is a OH here and a OH here. This is the structure of H2SO4. HNO3, nitrogen here. Through a dative bond, it is bonded OH. Now, what will happen is, when both of these combine, like previous mechanism also, like aluminium chloride and Cl2 everything, before we add to the benzene ring, both will react and form a thing like that. NO2 plus should form. Earlier mechanism also, electrophile Cl plus, Br plus. It is only forming in the first step. Then only it is going to react with the benzene. So first step is the formation of this electrophile. Okay. Then this hydrogen will come and combine with this oxygen. Then we will get O minus S double bond OH plus HO H N double bond oxygen. Then what happens? This will break and it will give us water molecule plus NO2 plus. Here NO2 plus electrophile is formed. Then what happens is, let's say this is our benzene ring. Okay, this rich in electrons. So NO2 plus, it is going to give its electrons to NO2 plus. Okay, then we can draw the structure. Okay, this bond will break. What happens? This bond will break and NO2 will come here. Hydrogen we should show there. Since this bond break, there is a plus charge here. That plus you should show. This we call as the intermediate carbocation. Intermediate carbocation. Then hydrogen will give it here. So there is a, this we can write as this also, COSO2OH minus. Okay, this OSO2OH minus, it will give its electrons to hydrogen. Then what will form is benzene ring with NO2 plus this one and this one will combine and form H2SO4. So if you want, you can show the intermediate carbocation involving resonance. Now this one, its resonance structures you can draw. So here plus sign is there, NO2 here, hydrogen here. In order to neutralize this plus sign, this pi electron cloud will move here. Then what we will get? We will get a structure like this. NO2 here, hydrogen here. Okay. Then since this electron moved here, this carbon get a plus. Then the next possible resonance, NO2 here, hydrogen here. This will move to this position. Then the plus here. So these are the resonance structures the intermediate carbocation involves in order to stabilize even more. Okay, that is the advantages of benzene. Rather than normal compounds, it involves so many resonance structures and gets more and more stable. Did you get this?
Yes.
Hello.
Yes, Miss, understood. Miss, done.
Now write down this question, the questioning mechanism. So I will give 5 answers. You have to select one. Which of the following represents a correct step in the mechanism of nitration of benzene? Which of the following represents a correct step in the mechanism of nitration of benzene? So first answer, then so 4 are wrong, one is correct. You have to identify the correct. Okay. So what is the question is, which of the following represents a correct step in the mechanism of the nitration of benzene? So first one, if you consider first one, it is wrong. Why? Because NO2 plus means what? It needs electrons. It don't have that much of electrons. Okay? Can it give electrons to benzene ring? No, the mechanism other way around. But we learn, we have benzene ring. In benzene ring only it is giving electrons to NO2 plus. Okay? That's how we learn. So this arrow mark is other way around. Therefore, this step is wrong. Okay? This one is correct, but this one is wrong. So what is this is? It is giving electrons to NO2 plus. Now, why this one is wrong means this part is correct, but this part is wrong. But one reason is there can't be two hydrogens in this position. This one, now what happens is when it gives NO2 plus to this, so you know benzene ring is like this. There are 6 carbons. This is the normal position of the benzene ring. In between double bonds, hydrogen here, hydrogen here, hydrogen. Okay. So this is the normal benzene ring structure that only we are representing in this. So even if one of these bond removes and NO2 gets attached, this bond removes and NO2 get attached. One is this carbon, no plus. 1, 2, there are 4. So this carbon only will gain the plus. So plus is in the wrong position. That is one wrong. And hydrogen, 2 hydrogens in one carbon. There can't be 2 hydrogens. Even if the double bond gets removed, the carbon will get the plus sign, it can't be 2 hydrogens. Therefore, this step also in the mechanism it is wrong. So what is then third step? So third step you will see why it is wrong, why NO2 it is giving to NO2 is coming here. The reason is not NO2, it is NO2 plus. That electrophile should be there in every mechanism. Cl plus, Br plus, R plus, CH3C double bond O plus. We discussed 5 major mechanisms, right? Alkylation, acylation, chlorination, bromination, and now nitration. All these 5 mechanisms are electrophilic substitution reactions. So in the first reaction we discussed RCl in the presence of anhydrous aluminum chloride. R plus is the electrophile. Next one is CH3C double bond O plus, that acid chloride. Then Cl plus, Br plus, similarly NO2 plus. All these electrophile are going in search of benzene ring because it's electron rich, and what happening, it is getting substituted, electrophilic substitution. Here is NO2. So NO2 is not the electrophile, no, NO2 plus. Therefore, that one is wrong. Therefore, this one is wrong. So what about the fourth answer? Fourth answer is correct. You see, here is NO2 here, hydrogen here. This is the final step. Hydrogen is giving its electrons here because there is a plus created now here. So what happens in the mechanism, hydrogen will give. So hydrogen loses its electrons. So HSO4 minus will give it to hydrogen. Then NO2 will come and H2SO4 will come. So why does this answer is wrong means there can't be 2 hydrogens, same reason. So therefore fourth one is the correct one. Okay. Hello.
Okay.
Okay. You can choose now if they ask like this. If they give 2, 3 or 4 steps in the mechanism and which one is the correct one? Any doubts?
Yes, miss. No, miss, clear.
Okay, write down this. And write down the reason why we are cutting the first one and second one. First one, arrowhead is wrong. Second one, there can't be 2 hydrogens and the plus is wrong. Plus can't come here. No, sorry, plus is correct. Because it's the other way around, no? There's a double bond here. There should be a bond here. This one is removed, so plus can come here. It should come here, not here. But they gave it here, therefore it's. There can be 2 hydrogen. That is the reason. Even if the double bond gets removed in the benzene ring, double bond gets removed, there will be a plus here, but it can't be 2 hydrogens. That is the wrong.
Miss done.
Okay. So these are the 5 major mechanisms they can ask and the reactions of benzene. Now you write down next set of reactions of benzene. Okay. Before that, okay. Let's talk about a small property, a bond length property. A bond length and hybridization. Alright, let's finish the reactions and come. Okay. Next, you put the heading oxidation. Okay. Oxidation. And write down under that to oxidize, at least one hydrogen should be present. To oxidize, at least one hydrogen should be present with sp3 hybridized carbon, which is directly bonded with benzene ring. To oxidize, at least one hydrogen should be present with sp3 hybridized carbon, which is directly bonded with benzene ring. To oxidize, at least one hydrogen should be present with sp3 hybridized carbon, which is directly bonded with benzene ring. Okay. And put example. So this is a benzene ring. Okay. Now I will denote benzene ring like this. We can write like this also. No? See, now this is the compound. There is a hydrogen here. There is a R group here, R group here. R group means it can be CH3 or CH3, CH2, like that. Alkyl group. Huh? What I am denoting as R is alkyl. So when I add H plus MnO4 minus, okay, to oxidize, what I am adding is H plus MnO4 minus, the oxidizing agent. Okay, so to oxidize, the theory what they are telling is to oxidize, at least one hydrogen should be present with sp3 hybridized carbon, which is directly bonded with benzene. Okay, now this carbon to oxidize, now the carbon, this is the carbon which is directly bonded with benzene. Let's say this R group is some CH3, CH2 like that, or this R group is CH3. So the carbon which is directly bonded with benzene ring, if it is has one hydrogen, at least one hydrogen, no, they are telling to at least one hydrogen, there can be one hydrogen or more hydrogens. At least minimum 2 hydrogens should be present. What it will do is this whole thing will be converted into COOH, which we call as carboxylic acid. COOH is carboxylic acid. So oxidation reaction outright is if a carbon which is directly bonded with benzene ring, if it has one hydrogen, when we put oxidizing agent, what will happen is this whole thing will change as carboxylic acid. But if they give a case like this, benzene ring here, carbon, no hydrogens. There is a CH3 here, CH3, CH2 here, okay, CH3, CH2 here, and a CH3 here. Here, according to theory C, the benzene ring, the carbon which is attached to benzene ring has no hydrogens. See, directly no hydrogens, no. This hydrogen belongs to this carbon, directly no hydrogens. In this case, if we add H plus MnO4 minus, no reaction, it won't get oxidized. In order to get oxidized, the carbon which is directly attached to the benzene ring, it should have at least one hydrogen. Then only when you add the oxidizing agents, any oxidizing agent H plus MnO4 minus, H plus K2Cr2 also, it will get oxidized and this whole thing will change as COOH. Benzoic acid we call that. This one we can name benzoic acid. But in this case, it won't get oxidized. Okay?
Okay.
Right.
Miss done.
Okay. Now using this theory, I'll give you small question to write the product. So this is the benzene ring. CH3, CH2, CH3, CH3. For this, I am putting oxidizing agents, H plus, MnO minus. So what should be the product? And this one, benzene ring, okay. CH2, CH3, and here carbon, CH3 here, CH3 here, CH3 here. So if I put H plus, MnO minus, what is the product? Okay. So how to write down the product? Now, what is the theory we told? H plus MnO minus. Now we are putting an oxidizing agent. The carbon which is directly attached to the benzene ring, if it has at least one hydrogen, it will get oxidized. See, this carbon, it is directly attached to benzene. It has 3 hydrogen. At least if it has one hydrogen, it will get oxidized. It has 3. So definitely, one, it will get oxidized to carboxylic acid. So that will convert to COH. Now this one, the carbon, which is directly attached to benzene, it has 2 hydrogen. CH2, CH3 means what is that? Now here, what is the structure is, CH2, CH3 means there are 2 hydrogens here. This is the structure, CH2, CH3. That only we are writing like this. So the carbon, which is directly attached to benzene ring, if it has at least 1 hydrogen, it will definitely get oxidized. There are 2 hydrogens. So definitely this will get oxidized to carboxylic acid. Similarly, CH3 also carboxylic acid. Okay. Now look at this question. This is benzene ring, CH2, CH3, and CH3, CH3, CH. Now what we are adding? We are adding H plus MnO4 minus. Now this one no problem, but similar to this, it will get oxidized to carboxylic acid. But this one, when you consider the carbon which is directly attached to the benzene ring, at least there should be 1 hydrogen to get oxidized. But here see, nothing is hydrogen. Everything are group. CH3 group, CH3 group, CH3 group. Therefore, this won't get oxidized. Now, this is a question like, this part the compound is being oxidized. This is not being oxidized. Then how to write the product? Here, it won't get oxidized means you can't say no reaction. In the earlier case, we had only this. In that case, if you had H plus MnO4 minus, we told, but it doesn't have any hydrogen, therefore it won't get oxidized. But this has hydrogen, no? So this part will get oxidized. This part will remain as it is. It won't react. Therefore, you have to write it here, C, CH3, CH3, CH3. It will remain as it is. Okay? So these are the 2 types of questions they can ask in this reaction. This is a tricky question. See, CH2, CH3, carbon, CH3, CH3, CH3. Right? H plus MnO4 minus. Sometimes we get confused. So this won't react. This one give carboxylic acid because no hydrogen, but this will react. Then if there is a reaction or not a reaction, there will be reaction because this will react to CH2, CH3. So it will give carboxylic acid. This won't react. This it will remain as it is. Okay? Write down the. You get the last one?
Yes, Miss.
Okay.
Miss done.
Okay. Under that, you write this short also. The number of COOH group formed, depend on the number of alkyl group other than tertiary carbon. The number of COOH group formed depend on the number of alkyl group other than tertiary carbon. The number of COOH group formed depend on the number of alkyl group other than tertiary carbon. Okay, but what I'm telling is, see here there are 3 COOH group because there are 3 alkyl groups. Other than tertiary carbon, what does that word mean? This is tertiary carbon. See, carbon with 3. In this case, it won't be COOH. So what we have written, it is described in words. Okay. So now we looked at the 5 major reactions: alkylation, acylation, chlorination, bromination, nitration. There are some other reaction also, hydrogenation like that. So the subtopic. So what we look at those 5 reaction earlier, keep it in mind. All that 5 major reaction mechanism, those 5 reactions are electrophilic substitution. And remember the electrophiles. First reaction RCl, R plus is the electrophile. Next one is CH3, C double bond O Cl, CH3, C double bond O plus. Then bromination, Br plus. Then chlorination, Cl plus. And next one, nitration, that is NO2 plus. And we are using catalyst also. Aluminium chloride, those are the other things we are using. And mechanisms, and if they are switch step is not there. And oxidation also, they can ask reaction like this. They can give the answers in the product and choose the correct one. Okay, next one. Within that subheading, next one you put hydrogenation. Now, up to now, what we did is, for a normal benzene ring, we added E pluses. That E plus means Cl plus, Br plus, R plus, RC double bond O plus. This you can put a short note and keep like that. R plus, electrophilic, that 5 major reactions. Those are the really important ones. RC double bond O plus, Cl plus, Br plus, NO2 plus, all come under E plus. E is the R, RC double bond O plus, Cl, Br, NO2 plus. Okay, and what is the product it gave is E. The electrophile went and attached here, and the mechanism we study is electrophilic substitution. Substitution. This is what we discussed up to now with those mechanisms. Okay. So now what we are going to discuss is hydrogenation. Okay. For a benzene ring, what I am going to add is H2 nickel catalyst. H2 nickel catalyst. Okay. Then what happens is, all positions hydrogen will get attached. So normally there is one hydrogen. We are not depicting it. But here all the double bond will break. Okay. And hydrogen will come in all position. This we call as hydrogenation reaction. So if it is difficult to understand, so what is happening here is, there are 6 carbons in the benzene ring. Okay. There are 6 carbons. This is the benzene ring. Normal benzene. Hydrogen here, hydrogen here, hydrogen here, hydrogen here. In between, there is double bonds. So when we put H2 nickel catalyst, you would have studied this reaction for what? Alkenes also. Alkenes also we put this and reduce to alkane. H2 nickel catalyst. Same here. Here when we put H2 nickel catalyst for benzene, what happens is, this double bond breaks. This bond will break, this bond will break, and this bond will break. And all the positions, it will be filled with hydrogen. And all the positions, it will be filled with hydrogen. That's what we are showing here. So here, this carbon chain, normally we don't show the hydrogen. So in order to earn the hydrogen is getting substituted, we are showing the previous area hydrogen also. So this is the product. So hydrogenation reaction, what is happening means, for a benzene ring, when you had H2 nickel catalyst, all the double bonds, and 3 double bonds in benzene ring. There's a cyclic structure, double bonds break, and in every carbon, one hydrogen gets attached. And therefore, that is the product. Okay, we are putting a catalyst in order to pass the reaction. The catalyst we are using here is nickel catalyst. Okay.
Okay, Miss.
Okay, right. If the meeting ends, rejoin. sometimes you can write they use the word 3 moles of hydrogen also. Mostly they use H2 nickel catalyst. Sometimes in some papers they use 3 moles of hydrogen. Instead of H2 nickel catalyst, you can use that. Because there are 6 hydrogens getting substituted. No? You have 3 moles of H2. Okay. So what is the mechanism of this reaction? Free radical addition. The free radical addition reaction. Okay. This is the mechanism of hydrogenation of benzene. Free radical addition reaction, not electrophilic substitution. Electrophilic substitution reaction is those 5 major reactions: alkylation, acylation, bromination, chlorination, nitration. This come under mechanism free radical addition reaction. What we are doing for a benzene ring, we are adding H2 in the presence of nickel catalyst. So the double bonds are breaking, and every place one hydrogen is being, new hydrogen is coming. So normally we are not showing the hydrogen in the benzene ring. Since another hydrogen is coming, we are also showing the previously attached hydrogen also. That's why I've shown both the hydrogens. And if they ask the mechanism, what is the mechanism when we add benzene ring to H2 nickel catalyst, you must write free radical addition reaction.
Okay, Miss. Done.
Okay. And this, what is the name for this is cyclohexane. By cyclohexane means this is a cyclic structure. Okay, there are 6 carbons. Hex means 6. No, there are 6 carbons arranged in cyclic structure. No double bonds are there. Hexane, alkane, alkene, alkyne. Alkane means ANE means by putting is all the double bonds are being broken and single bonds are only there. Therefore, ane. Hex. Why hex means there are 6 carbons. By cyclo, I'm telling you, see the cyclic structure. So what is the product produces? Cyclohexane. Sometimes they can use that paper in the but how to produce cyclohexane, what type of reaction. Rather than giving this compound, they can use this word also. So better to know the name cyclohexane. Okay. So next one. So we can add compounds like these also now for a benzene ring. Now here what we wrote is H2 in the presence of nickel catalyst. Whereas I wrote 3 moles of hydrogen. Sometimes we can put like 3 moles of chlorine. So that is not like a major reaction like this. Okay. So that is also one of the reactions in the benzene ring. So what happens is, if I put 3 moles of chlorine, here 2 hydrogens I showed. Here 1 hydrogen, chlorine. So this is the product we will get. Hydrogen here, chlorine here. Hydrogen here, chlorine here. This hydrogen is already their hydrogen. That only I am showing. No new hydrogen. I hope you can understand now. But what I am telling here is 3 mole of chlorine means a normal benzene ring is this. No, normal benzene ring is there are 6 carbons like this. Okay, there are 6 carbons like this. Hydrogen here. Okay, in between there are double bonds. That is the normal benzene. Here, when I put 3 mole of chlorine, what is happening is these double bond, these 3 double bonds will break, and every position one chlorine is being attached. Every position one chlorine is being attached. Not hydrogen is coming. Why I am showing the hydrogen is in a benzene ring there are normally 6 hydrogens. So that's why I am showing those hydrogens. Here what is being attached is chlorine. So what is the reagent I am putting is 3 mole of chlorine. Okay. Similarly, if you put any other thing, these come under free radical addition reaction. So you put 3 mole of chlorine. Similarly, if you put 3 mole of bromine and everything, all 6 position will fill with bromine. What happens? The double bond is being break, and this is being attached. Then we can call this as hexachlorocyclohexane. So what is the name for this? Hexachlorocyclohexane. Okay, this is cyclohexane. But there are 6 chlorine atoms now. 6 chlorine atoms is being attached. Therefore, what is the name for this is hexachlorocyclohexane. Okay, write down the. This also come under what? Free radical addition mechanism. Free radical addition.